two particles each having a mass m are placed at a separation d in a uniform magnetic field B as shown in figure. They have opposite charges of equal magnitude q. At the time t, the particles are projected towards each other, each with a speed v. Suppose the Coulomb force between the charges is switched off. Find the maximum value of the projection speed so that the two particles do not collide. Find. In the first part, we have a condition that the velocity v is given to both of them, but the particles should not collide. That means the radius of both of them should be just equal to d, so that each of the particle can trace complete circle without collision. Fine. So 2 times of r should be equals to d. Right. Now one thing I have to make clear, that since the charges are opposite, so q is equals to v cross b, centrifugal force will be towards center, and for this particle b, v cross b, so it will be again towards center, so both will be rotated in the same orientation. So 2r will be equal to d. I have to calculate the maximum velocity of projection. R is given by mv by qb is equals to d. So v max will be equal to qbd by 2m. That is the answer for the first part. In second part, what would be the minimum and maximum separation between the particle if v is equals to vm by 2? At that instant, fine. Now if v is equals to vm by 2, then I have to calculate minimum and maximum distance between both of them. Let's say this is my particle A, this is my particle B. Each of them will trace a circle like this. Fine, this is my distance d. The radius r of both of them will be equal. So I have to calculate the minimum distance. So minimum distance will be equal to d minus 2r, and of course maximum distance will be equal to d plus 2r, because again this distance is r, this distance is r. So when the particles are at this point, they will be at a minimum distance, and when both the particles are at this points, they will be at maximum distance. So I know the value of d. I have to calculate the value of r in terms of d. So the value of r can be written as mv max mv by qb. Fine. And velocity is given by vm by 2, vm by 2 into qb, and the velocity of vm is given to me as qbd by 2m. So it get cancelled, qb get cancelled, it comes out to be d by 4. So 2r is equals to d by 2. So minimum distance will be equal to d by 2, and the maximum distance will be equal to cd by 2. That is the answer for the B part. In the C part, at what instant will a collision occur if the particle have a velocity v is equals to 2m? Fine. Now let us say this is my C part. Both the particles are projected like this, and they collide at this very point. Alright. This is my figure. So this distance is my d, and this is my r, this is my r. Let us say this is theta, this is also theta. So this angle can be written as r sine of theta, and so this will be also r sine theta. So I can write 2r sine theta is equals to d, and r is equals to m v by qb is equals to sine theta into d. The velocity is given by 2 times of vm, so it will be 4 m vm by qb sine of theta is equals to d, and we know that vm is given by qbd by 2m, so 4 times of m by qb into qbd by 2m sine of theta is equals to d. So qb by m cancel, this is 2, d is cancelled, theta comes out to be 30 degree. Fine. Now I have to calculate at what instant. So for that I have to calculate the value of omega first of all. So omega comes out to be qb by m. Fine. And we know that omega is equals to theta by t. So t is equals to theta by omega. Just substitute the value, you will get the answer. In the D part, suppose v is equals to 2m, that was in the C part, and the collision between the particle is completely inelastic. Describe the motion of the collision. Fine. Now if the motion is completely inelastic, then both of them will stick together, right? Both were having a velocity earlier in this direction. Fine. So if I take the component, this angle is 30, this angle will be 60 degree, this angle will also be 60 degree. I make the components of the velocity of both of them, that is v cos of 60 in this direction and v sin of 60 in this direction. And similarly for this, v sin 60 in this direction and v cos 60 in this direction. This v cos 60 and this v cos 60 will get cancelled because they are equal and opposite in direction, and this velocity will add up. So it is very clear that the motion of the two particles will be a straight line because they are having the velocity only in one direction. So the motion is straight line with a constant velocity. And that will be equal to 2v sin of 60. Fine. This is the motion just after the collision, and if we talk long after the collision, I mean seconds after the collision, then it will be a circular path, right? And the mass will be 2m, velocity is 2v sin of 60 as I told you, right? Magnetic field is given to me, so they will rotate in a circle, that will be given by mv by qb. That is the answer.